The next law of exponents is the quotient rule. So when dividing by the same base, you subtract your exponents. All right, so this rule I learned when I first taught algebra is to take the smaller exponent, bring the smaller exponent to the larger exponent, change its sign. It saves you from having to worry about negative exponents where they're not supposed to be. You haven't done negative exponents yet, so you're not going to see them quite yet, but it saves you from seeing those now. And then put this in with the quotient rule because it's part of it, is anything that is 0 is 1. Okay. So here's what I'm talking about. We have 12 to the 17 divided by 12 to the 20. Our base is the same, base 12. So we can subtract the exponents. Well, which exponent is the larger exponent or the smaller exponent? 17. Okay, so we're going to cross this out. We're going to put a 1 in its place because that's what's there. And we're going to bring the 17 down. That was a positive 17. So now we're going to subtract it and change it. So I've got 1 over 12 to the third. Because 20 minus 17 is 3. Example 2, the bases are the same, x and x. 7 is the smaller exponent. Put a 1 there in its place, bring it down. It was positive, now it's negative. So 1 over x squared. In example 3, y to the 20 divided by y to the 24. Y's are the same. Okay, 20 is the smaller exponent. Bring it down. It was a positive 20. Now it's a negative 20. So 1 over y to the 4. Well, then we start using it in conjunction with other parts. Okay, reducing fractions. Okay, so what I mean by that is on example 4, we have 5 over 25. Well, both of those can be divided by 5. 5 goes into itself once, and into 25 5 times. And your x's, you have x squared over x to the 7. Bases are the same. So divided by the same base, you subtract your exponents. 2 is the smaller exponent. So bring it down. It was positive. Now you're subtracting. So what's still left in the numerator is 1 because you've canceled everything else out. What's still left in the denominator? You have the 5. And then the x to the 7 minus 2. So x to the 5th. Example 5. Start with the negative 12 and the 4. Both of those can be divided by 4. 4 goes into itself once. It's a negative 12, negative 3 times. Y to the 8th, y cubed. Divided by the same base, subtract your exponents. In this case, the 3 is smaller. Let's put a 1 in its place, bring it up to the 8. That was a positive 3. Now you subtract. So what I've left in the numerator is a negative 3. And then y to the 8 minus 3 is y to the 5th. Then you have a 1 in the denominator. You don't need to keep a 1 in the denominator. You do need to keep a 1 in the numerator, but not denominator. Okay, we have negative 16, negative 24. Both of those can be divided by negative 8. You want to get rid of the negative sign as well because negative over negative is positive. So negative 8 goes into negative 16 twice and into negative 24 3 times. Dividing by the same base, you have x's. Subtract your exponents. The 7 is smaller than the 8. Bring the 7 down. It was positive. Now it's negative. So you've got a 2 times 1 in the numerator and a 3x left in the denominator. And that x comes from 8 minus 7 is 1. Now you can put the 1 there. You don't have to though. It's understood. Now adding in other variables. The rules don't change. Okay, so starting with a negative 20 over 28, those can be divided by 4. Negative 20 divided by 4, negative 5. 28 divided by 4 is 7. All right, and here's where a zero product comes in, and this is why anything to the 0 power is 1. All right, so I want to do this kind of down here. You have a cubed over a cubed. Okay, well, we know a number divided by itself is 1. Okay, but using the quotient property, well, that's a to the 0, but it was a cubed over a cubed, which was 1. So anything to the 0 power is 1. So going back up here, a cubed cancels a cubed. You have a 1 in its place. We got b to the 7, or b to the 8 and b to the 7. 7 is the smaller exponent. It was a positive 7, now it's a negative 7. You also have the c. This time 4 is the smaller exponent. Bring it down, it was positive, now it's subtraction. All right, so we kind of have to navigate what I still have left. From the negative 20, that became negative 5, divided by 4. We cancel the a's, put a 1 in its place. B to the 8th became b. And c has a 1 in its place, so I don't need it. Across the denominator, I've got 7. And then a we canceled. B we canceled because it went to the numerator. Then we have c to the 5 minus 4, which is 1. Okay, this is all multiplication, which is why you don't see the 1s anymore, because it's negative 5 times 1 times b times 1, which is negative 5b. All right. Start with their 5 and the 10. Can both be divided by 5. 5 gives itself once, and into 10 twice. We have x to the x to the 0 and x to the 4th. X to the 0 is 1, so I'm just going to cancel that out. We don't really need it, which means your x to the 4th is going to stay where it's at. Then you have y to the 6th divided by y to the 8th. 6 is a smaller exponent, so bring it down, subtract. All you have left in the numerator is a 1 and a 2. In the denominator, sorry. X to the 4th, and then y to the 8 minus 6, y squared. All right, so in example 9, you should start with the coefficients, but you have an 8 to the 0 here. 8 to the 0 is 1, which means I don't really need to do anything with the 4 and the 1 because I've already done it. You also have an x to the 0 up here, so that is 1 as well. You've got y squared by y to the 5th. 2 is your smaller exponent. And you don't have any z's to mess with, so you just leave that one alone. So up in the numerator, you simply have 4 because everything else was a 1. Denominator, you have y cubed because 5 minus 2. And z cubed because there weren't any other z's. So once you get done with this section, I want you to do the next 2 sections of your 5.1 assignments. This is section 2 and 3.